Yes. So good morning all. In the last class we have seen the node voltage analysis of electric circuit. Okay. And also we have seen an example, a problem solved on node voltage analysis. But that problem was simple because uh, there was no voltage source between the two nodes. Like we got a current source between two meshes, a common current source between two meshes, and that was a special case in our mesh analysis. We took a super mesh, okay, and then we solved that example. Now similarly in the circuit, if we wish to go for node voltage analysis, and if there is existing a voltage source, a independent ideal voltage source, okay, independent ideal voltage source, if it exists in between two nodes, principal nodes, okay, especially in between two principal nodes, then slightly the analysis will take a different mode than what we already have seen in the previous lecture. We'll look into what has to be done. Now, if there is a voltage source existing in between two nodes, and that voltage source is between two principal nodes, and that is an independent voltage source. Okay, maybe ideal or practical. If it is practical, some changes will happen. If it is ideal, then we have to see what will be the case here. Okay, so first we will look into that what we should be doing if there exists a voltage source. Then we will take one example based on that. Then we will try to get the solution. Okay, so first let us consider a circuit. Okay, I will consider some arbitrary circuit. Okay. Okay, so this is the circuit given. Now, I wish to mark the nodes. So there are four nodes: node 1, node 2, node 3, node 4. And out of these four nodes, I should be taking one node as a reference. Okay, so the more convenient node to take the reference is the node to which the maximum number of branches are connected, one, and the node which I will get more number of what I say common nodes. Okay, now here to this node, all the three nodes are connected. Okay, so I will be taking this as ground, the reference node, and I will mark the other principal nodes. This is node 1, this is node 2, and this is node 3. Let us take voltage V1, voltage V2, and voltage V3. Okay. So now what I have to do is I should assign the branch currents. Okay. So the direction of current here, it is I2 and this is I3. These two are predefined because the direction of source itself is been directly given. So this is I2. Let us take this as I4. I will take this as I5. This I will take it as I6. Okay. Now what should I do with this node. Okay, so I have a voltage source. I have a voltage source in between node 2 and node 3. Again, I have here two ways to analyze. One, I can assign some arbitrary current to that source or to this branch. Then I shall apply KVL to that. But again, like I discussed in the previous section of super mesh analysis, that if you do that, the number of unknowns will be more than the number of equations sometimes. Solution becomes more tedious. Okay, so therefore, we will not follow that. Rather, we will follow the second method, which is known as super node analysis. Okay, we will follow super node analysis. I will take super node analysis. So I will form a super node. What is super node? Super node is nothing but combining both the nodes between which a voltage source is existing. Okay, so super node is it is a combination of both nodes, between which the voltage source is existing. Voltage source is existing. So now I have to take node 2 and node 3 as one node. Node 2 and node 3 as one node. After taking, what should I do? Then I should be writing the node equation or the KCL equation simultaneously for the supernode, considering the respective branch currents connected to the node. Okay. Then after that, write KCL equation simultaneously to supernode, okay, or combinedly supernode, taking respective branch connects connected. Branch currents connected to both nodes. Taking respective branch currents connected to both nodes. Okay. So this is what I should follow. So in this given equation, node 1 is independent. There is no much confusion in writing the equation for node 1. But whereas for node 2 and node 3, I have formed a supernode. So this is a supernode. This is a supernode. Now I shall have to write the supernode equation for node 2 and node 3. So first I will write equation for node 1. KCL at node 1. KCL at node 1. So I can write the same convention will be followed. Incoming current is positive, outgoing current is negative. So it is I1 plus I2 minus I4 minus I5 is equals to 0. Okay. So whereas I1 and I2 are the source values, they won't change. I1 plus I2, it is same, minus of I4 is, it is flowing between node 1 and node 2. So this is V1 minus V2 by R1. And I5 is between node 1 and node 3, V1 minus V3 by R3. Because current is from node 1 to node 3, it is V1 minus V3. Because current I4 is from node 1 to node 2, it is V1 minus V2. Okay. Simplifying this, we'll get some equation, we'll solve it. Because it is general circuit, we will not do that. Okay. Important thing is how to write the equation. Once you write the equation, simplification is a very simple task. It has you have practice of that. But understanding how to write the equation is of important consideration. Okay. Now second, KCL to supernode. Now, when I take supernode means what? I am combining these two nodes into one. Okay, and I will be writing the KCL equation for node 2 and node 3 simultaneously in one equation. I will be applying KCL for node 2 and node 3 simultaneously, and I will get only one equation for both node 2 and node 3. Now there is no difference between node 2 and node 3. I have combined it as one. That itself is known as supernode. Yeah, that itself is known as supernode. So now KCL to supernode, that is apply KCL to node 2 and node 3, node 2 and node 3 simultaneously and write in one equation. It is just for your understanding, for reference, this statement. Every time you need not to write in the solution. Okay, if you have to understand it, that's it. Now, apply KCL to node 2 and 3 simultaneously. Now, first you will apply for node 2. What are the currents connected to node 2? That is I1, I4 and I6 connected to node 3, I5 and I3. Okay, so at node 2, I1 is flowing out of the node 2. Okay, so it is minus I1, I4 is flowing towards node 2, plus I4, I5 is flowing away from the nodes 2. Sorry, I6 is flowing away from the node 2, plus minus I6. Okay, so there are three currents connected to node 2. Next, for node 3 there are two currents. I5 is entering, I3 is leaving. So plus I5 minus I3 is equals to 0. Plus I5 minus I3 is equals to 0. Okay, so this is the supernode equation. Now what is I1? It is a source value, it will remain as it is. Plus I4. I4 is from V1 to V2. So it is plus V1 minus V2 by R1. Next, minus I6 minus of V2 minus 0 by, I will write it as V2 by R2, because now we got to know that the other node is ground, so it is 0. Let us not put another term in the equation. Plus I5. I5 is from V1 to V3, so that is V1 minus V3 divided by R3 minus I3. I3 is a source value, is equals to 0. Now this is equation 1, this will be equation 2. But I have 3 node voltages and 2 equations, so I should be getting one more equation. Okay, one more node equation I should be getting. Now that node equation will give us the relationship between node 2 and node 3, or between the two nodes where the voltage source is existing in between. Okay, so third equation will be for this voltage source. So what is that voltage source? E. The positive terminal is connected to third node, negative terminal is connected to second node. Therefore, I can write V3 minus V2 is equals to 0. This will form third equation. Now I have got equation 1, equation 2, equation 3 in terms of V1, V2 and V3. Solve those three equations, we will get node voltages V1, V2, V3. Once I get node voltages V1, V2, V3, I can find the current in any branch because I will be knowing its impedance. Okay. Then I can find the voltage drop across any branch. I can find the power loss across any branch, power supplied by any source. I can do that. Okay. So this is all about node voltage analysis. Now I will take one example and we'll look into how to solve that. So we'll take one example. Find all the node voltages and voltage across 2 ohms. Find all the node voltages and voltage across 2 ohms in the circuit shown below. So this is a circuit shown. I need to find all the node voltages and voltage between 2 ohms. Okay, voltage between 2 ohms. I have to find it. Now you can observe some source values are given negative, minus 10. Simply, what you can do is, if you want, you can reverse the direction of the source and then write the equation, or you write the equation using the minus sign also considering in the value. So this purposely I have taken, okay, so that you should be knowing the other way of representation. Okay. Now I have 1, 2, 3, 4 nodes. One node I have to define it as the reference node. I will take this as reference node, okay, because most of the branches are connected to this reference node. Then I will take this as node 1, this as node 2, and this as node 3. So let it be V1, V2 and V3, and we have observed here that there is a voltage source in between node 2 and node 3. So I will define this as supernode. I will define this as supernode. Fine. Now I have to write the KCL equations for each node. Before that, I should be defining the direction of currents in each branch. So let this be I1, let this be I2, let this be I3, I4, I5, okay, I6 and I7. Any number of branches you have, so many number of currents you can take, because those values will not reflect in the equation. What reflects is the voltage values. So there is no harm even if I assign any number of currents for any number of branches. Okay. Now first I will write what is the equation for node 1, KCL at node 1. Apply KCL at node 1. So check all the branch currents connected to this node 1. Okay. So I2 is there, I3 is there, I4 is there, I1 is there. So there are 1, 2, 3, 4 branches connected. There will be 4 equations, 4 terms in that equation. Okay. So write KCL at node 1. So incoming currents are positive, outgoing currents are negative. So it is I2 is entering, minus I1, it is going out, minus I3, it is also going out, minus I4, it is also going out, is equals to 0. Okay, so what is I2? Okay, I2 is minus 4, this is I2, okay, not this is I3, this is I2. I2 is minus 4, minus I1, I1 is plus 5, minus I3. I3 is between node 1 and node 3, so that is V1 minus V3 divided by 10. Okay, and I4 is between V1 and V2, so this is minus V1 minus V2 divided by 2 is equals to 0. Is equals to 0. Okay. Now, minus 4 minus 5 is minus 9, minus 0.1 V1 plus 0.1 V3 minus 0.5 V1 plus 0.5 V2 is equals to 0. Or when I write, it is minus 0.1 minus 0.5, it is minus 0.6 V1 plus 0.5 V2, okay, then plus 0.1 V3 is equals to 9, is equals to plus 9. This is equation 1. Now, second case, writing KCL for supernode. KCL at supernode. Supernode 2 and 3. KCL at supernode 2 and 3. Let us take these equations as ABC, because you should not confuse between the node number and equation number. All will be node 1, node 2, node 3, equation 1, equation 2, equation 3. Okay. So let us take equation numbers as ABC. It is up to me, whatever the name I want to. Okay. Now writing the KCL at supernode. Okay. So I should be applying KCL at node 2 and at node 3 simultaneously. Okay. Simultaneously I should be writing. So at node 2, there are 3 branches connected with the currents I2, I4 and I5. So current I2 is leaving the node 2, it is minus I2. Current I4 is entering node 2, it is plus I4. I5 is leaving node 2, it is minus I5. So this is at node 2. Now next is at node 3. At node 3, there are again 3 branches connected except this voltage, because that is we are not assigning any voltage source to that. So there is I3 coming in, I6 going out, I7 going out. So it is plus I3 minus I6 minus I7 is equals to 0. Is equals to 0. Now write the current values. Now minus I2. So what is I2? It is minus 4 amperes. Now the value of I2 is minus 4 amperes and the term in the equation is minus I2. So this will become minus of minus 4. So only I have taken purposely this type, so that you will not get confused if you get to know directly this kind of values. Value of I2 is minus 4. I haven't changed the direction of source. Don't do that. Whatever value is been given, you take it. So value of I2 is minus 4. Current in that equation is minus I2. So the value of that I2 will be minus of minus 4 now in that equation. Plus I4. I4 is from V1 to V2. So plus V1 minus V2 divided by 2. Okay. Because direction of I4 is from V1 to V2. So I4 will be always V1 minus V2 by 2. If it is from V2 to V1, then it will be always V2 minus V1 by 2. That you should take care. Minus I5. So I5. Which color? I4. Yeah, minus I5. I5 is between V2 and ground. So it is V2 by 4. Minus V2 by 4. Plus I3. I3 is at node 3. Plus I3 is, it is from V1 to V3. So it is again V1 minus V3 divided by 10 minus I6. It is between node 3 and ground. Minus V3 by 5 minus I7. I7 is flowing away from the node 3. So it is minus I7. The value of that is minus 10. This is equals to 0. This is equals to 0. So now this is minus of minus 4. Okay. Minus of minus 4 plus minus of minus 10. So it is 14 plus 14. Okay. Plus 4 plus 10 plus 14. V1 by 2. So plus 0.5 V1 minus 0.5 V2 minus 0.25 V2. 1 by 4 is 0.25 V2 plus 0.1 V1 minus 0.1 V1 minus 0.2 V3 is equals to 0. So this is my equation. So this comes out to be 0.5 V1 plus 0.1 V1. So this is 0.6 V1 minus 0.5 V2 minus 0.25 V2. That is minus 0.75 V2. Minus 0.2 V3. Somewhere some mistake had happened. That's 0.1 V1 minus 0.1 V3. This is plus 0.1 V1, 0.1 V1 minus 0.1 V3. So this is minus 0.6 V3 is equals to minus 14. Now take this as equation B. Take that as equation B. So 0.6 V1 minus 0.75 V2 minus not 0.6 minus 0.2 minus 0.1 minus 0.3. Sorry for that mistake. Minus 0.3 V3 is equals to minus 14. Okay. Now this is equation B. Now I have two equations in terms of V1, V2 and V3. I need one more equation to solve. And that one more equation will give us the relationship between node 2 and node 3. That is supernode equation. Okay, between node 2 and node 3. Source equation, sorry. So, third equation is, see here, positive sign of the source is towards V3. So, that 20 volts will be V3 minus V2. So, it is V3 minus V2 is equals to 20. Or I can write minus V2 plus V3 is equals to 20. This is equation C. Now always keep the equations in terms of with the coefficients V1, V2, V3, I1, I2, I3 like that. Because in hurry what you may do is once you see this equation, you may enter the coefficient of V3 as V2 as 1 and V3 as minus 1. Because we don't think much when we entering, we will see the coefficients. There may be a possibility of making some mistake. Okay. So this is solving these three equations. Solving equation A, B, C. Solving equation A, B and C. I will not solve, I will directly get the answer, you can do that. So with this we will get V1 is equals to minus 9.44 volts. V2 is equals to 2.22 volts. And V3 is equals to 22.22 volts. You can cross check. You can cross check this. So these are the three node voltages. So V1 is negative. What does it mean? Now the potential of V1 is lesser than the ground potential. That's it. Potential of V1 is lesser than the ground potential. That is the meaning. Okay. So the reference node is at higher potential compared to V1. But whereas V2 is at higher potential with respect to reference node, V3 is at higher potential with respect to reference node. Okay. Now what I should get? I should get the voltage across V2 ohms. So V2 ohms is equals to, now I should be observing which is larger value, V2 or V1. So obviously from the value that is seen, V2 is larger than V1. So it is V2 minus V equals to 2.22 minus of minus 9.44. Don't forget to include sign there. So this is equals to 11.66 volts. Yeah, 11.66 volts. So this is how we are solving the supernode example. Yeah, we are solving the supernode example. We'll look into one more example and then we'll close for the day. We'll take one more example. the circuit given. Question is, find the node voltages and current through 4 ohms. Find the node voltages and current through 4 ohms. This 4 ohm resistors. Okay, current through 4 ohms. Now we have 4 nodes here. 1, 2, 3, and this is a 4th node. Okay, so down node is 4. It is 4th node completely. Okay, so one node I have to take it as reference. So I will take this as reference node, and I will name the nodes here. Node 1, sorry. Node 1, node 2, node 3. Okay. This is V1, V2, V3. Now there is a supernode formation between node 2 and node 3. There can be a voltage source, so this is supernode. We have to take the same type of analysis what we already have taken. Okay. Now assign the currents I1, I2, I3, let this be I4, okay. Let this be I5, and let this be I6. Any direction. You can simply take arbitrary directions of the currents and then go ahead. Okay. Now write equation KCL at node 1. KCL at node 1. Okay. Current I1 is entering, I2 is leaving, I3 is leaving. So I will be writing I1 minus I2 minus I3 is equals to 0. I1 minus I2 minus I3 is equals to 0. Okay. So I1 is 20 minus V1 as per the direction of current. It is from 20 to V1. So it is 20 minus V1. Minus I2. I2 is between V1 and ground. So that is minus V1 by 10. Minus I3 is between V1 and V2. So that is V1 minus V2 divided by 5 is equals to 0. So it is 2 minus 0.1 V1 minus 0.1 V1 minus 0.2 V1 plus 0.2 V2 is equals to 0. Okay. So minus 0.1 V1 minus 0.1 V1 minus 0.2 V1. So that is 0.4 V1 minus 0.2 V2 is equals to 2. That is the equation A. Okay. Next, KCL at supernode. KCL at supernode 2 and 3. So at node 2, there are 2 branches connected. At node 3, there are 2 branches connected. Okay. So I3 is entering, I4 is leaving at node 2. So this will be I3 minus I4. Then at node 3, I5 is leaving, I6 is leaving. Minus I5 minus I6 is equals to 0. Now what is I3? Is between V1 and V2. That is from V1 to V2. So that is V1 minus V2 divided by 5 minus I4 is between V2 and reference. That is V2 by 2 minus I5 is between V3 and 16 volts. Not reference. It is between V3 and 16 volts. So it is from V3 towards 16. So with respect to the direction of current assigned in the circuit, V3 is assumed to get higher potential than 16 volts. Hence, I will take V3 minus 16 divided by 4. Okay, V3 minus 16 divided by 4. I6 is between V3 and reference. So that is minus V3 divided by 2 is equals to 0. Simplify. 0.2 V1 minus 0.2 V2 minus 0.5 V2 minus 0.25 V3 plus 16 by 4 is 4 minus 0.5 V3 is equals to 0. So 0.2 V1, only one, 0.2 V1 minus 0.2 V2 minus 0.5 V2 minus 0.7 V2, then minus 0.7 V2 minus 0.25 V3 minus 0.5 V3 minus 0.75 V3, okay, is equals to minus 4. This is equation B. Now, third equation will be voltage between node 2 and node 3. Voltage between node 2 and node 3. That is, now V2 is a higher potential with respect to V3. In this case, it will be V2 minus V3 is equals to 10 volts. Now, this is equation C. Now, solve equation A, B and C. We get V1 equals to, V2 equals to, and V3 equals to. So, V1 is 9.62 volts, V2 is 9.25 volts, and V3 is minus 0.74 volts. Minus 0.74 volts. Okay, you can verify these values. Next, I have to find the current through 4 ohms. Current through 4 ohms is equals to nothing but my I5. Okay, so what I have taken I5 to be V3 minus 16 divided by 4. That is V3 is minus 0.74 minus 16 divided by 4. Okay, this is equals to, okay, minus 4.185 amps. Okay, but actually here I can write. What does minus sign mean here? Minus sign mean the current direction is reverse than what is been assumed. So I5 is assumed to be V3 to 16 volts. Now actually I4 ohms is equals to minus I5. That is 4.185. It is flowing from 16 volts battery towards the node V3. So this is the supernode analysis. The things are done here for understanding of the concept rather than solving more number of solutions. Okay, more number of problems. Okay, these sessions are intended to understand the concepts, to brush up the concepts which already you have been studied. Okay, so today we will end the node voltage analysis part. This will be the end of module 1. Okay, this will be the end of module 1. Okay.